This episode is sponsored by Meter, the company building networks from the ground up. Meter delivers a complete networking stack, wired, wireless, and cellular in one solution. With Meter, you get fast, secure, and scalable connectivity without the burden of managing multiple providers or tools. Meter scales from branch offices, warehouses, and large campuses to data centers, and its integrated network stack is designed to give you deep control and visibility. Meter covers everything from first site survey to ongoing support, giving you a single partner for all your connectivity needs. Thanks to Meter for sponsoring. Go to meter.com/packetprotector to book a demo now. That's meter.com/packetprotector to book a demo.
Hey everybody, and welcome to this week's episode of Packet Protector, the podcast at the intersection of networking and security. I'm Jennifer J.J. Manella here with my co-host Drew Conry Murray, and we have a couple of amazing guests for you today. We have Rich Mogull, who's the Chief Analyst at the Cloud Security Alliance. He's also the creator of Cloud SLAW, which is a free cloud security lab a week. If you're interested in that, also check out episode 8, where we dug into that with Rich a while back. And then we also have Aaron Turner, who's IANS faculty. These guys are going to be actually giving a talk on model context protocol and agent-agent communications, including OAuth at RSA. So we thought we'd have them on, and let's talk about OAuth.
Yeah, so JJ, in our notes, we called this an OAuth primer, so I thought we'd dip our toes in, but I felt like by 10 minutes in, we were neck deep, so buckle up.
Yeah. We need like a whiteboard, a visual whiteboard for this one.
This would have been good with slides. Anyway, we're going to start with sort of a brief tour of some essential identity concepts. Then we'll talk about some OAuth basics. OAuth is authorization for humans and non-human entities, and we'll get into some of that. You can imagine agentic AI comes into the picture. We'll dive into some attacks being used against OAuth and why you want to pay attention. We'll talk about some non-negotiable steps if you are working with OAuth and ways for you to go find out how OAuth is being used in your organization if you want to start looking at it. A ton of great information and a really good show, so we'll dive right in. So guys, thank you for joining us. Let's just set the table with some kind of high-level essentials on identity and access management before we dive into OAuth.
Yeah, so I've been teaching like IAM stuff for a while, and I found that security professionals who come in, we don't always cover that unless you've like spent a lot of time on IAM. So I like to just break it down in a few minutes, like really simply, because it'll help make a lot of what Aaron and I are going to talk about it'll give you a little bit more context. So the first is, all of us here, we're entities. Entities are things. It can be a person. It can be a device, can be an entity, code, an agent for AI. Those are all what we call entity. That is the thing. Then we have an identity. And this is where people get a little confused. And with the OAuth stuff we're going to get into, this actually really makes a difference. An identity isn't like Rich Mogull. An identity is it's unique to a given namespace. So it's the representation of that entity within a namespace. What does that mean? I have email rmogull@cloudsecurityalliance.org. So my identity is rmogull@cloudsecurityalliance.org. Me as an entity, I also have another identity that is rmogull@securosis.com. cloudsecurityalliance.org and securosis.com. Those are the namespaces where that identity lives. There's going to be a big deal as we kind of get into OAuth and these other things, because it's all about managing like what entities can do and identities across these different namespaces. Then we get into other stuff like an identifier, which is how do you prove your identity? It's usually something, cryptographic is eventually, because that's the actual proof when you go to do something. It's not necessarily logging in, which is authentication. And then there's authorization. And I think most people know authentication, auth-n, authorization, auth-z. Authenticating is proving you are who you say you are, so the proving that you are that identity. And authorization is what are you allowed to do? So those are, the policies, the access controls of what you're allowed to do. And there's like all sorts of other stuff in there. But fundamentally, if you can keep that mapping that there's an entity that has an identity, which is that entity's representation in a namespace, and then you prove who you are with authentication, the rules around what you're allowed to do is authorization. That really will like play out as we kind of get into like OAuth and everything else, which gets us into this realm of federation, which is when we're starting to deal with making trust relationships across these various namespaces. Aaron, anything to add, or you think I covered that pretty well in like 2 minutes?
A great overview. The only thing I would add is, thinking about prepping for this conversation today, why is it that infrastructure people may not feel comfortable in modern identity? Like what's the root cause of that? And I think really it's because SAML and OAuth happened in the consumer identity world much faster than they happened in the enterprise identity world. And most of the folks who are listening are probably enterprise focused, right? They grew up in the world of this is my enterprise IT stuff. And so because of that fast acceleration in the consumer space, on the enterprise side, they were just like, oh, single sign-on federation identities, what Rich just talked through, that's what Okta does for me. That's what Ping does for me. So they perceived it as the solution that was foisted upon them, not necessarily something they participated in. And so I think the best way to think of this is to ground yourself in that which you know. So I started doing identity in the mid-90s. I was on the team that helped develop Active Directory, and so I'm going to use some old school Active Directory.
But we love you anyway, Aaron, despite that.
I'm an old codger, right? So I think
I still haven't forgiven you for that, but
yeah. So I think the way you should think about this as NTLM is to Kerberos, SAML is to OAuth. All right. So for example, what sucked about NTLM? Really easy reversible tokens, right? NTLM can be, Mandiant just had a press release this morning about, look at these rainbow tables. It's like, that's 25 years too late, but whatever. So, easily reversible, the sort of thing that goes on, right? Mm-hmm. Kerberos came about because you needed things like constrained delegation, the ability to say, this person's logging into this system, and I'm going to take that Kerberos ticket and forward it to the database so I have traceability through the system, right? And so that's something we all knew, because if the Kerberos token was 5 milliseconds out of whack, then the whole thing broke, right? And it just didn't work. And that's something that networking people would really understand, is that, your network time is off, it's not going to work. Yeah. The same thing holds true for OAuth now, right? Just like you had constrained delegation for Kerberos, so too you have delegation for OAuth, where you take an identity, as Rich discussed, this identity that represents a person in a certain context or namespace that can be used for one thing, but that destination can then reuse that token to take it somewhere else if it's properly set up, and it can use that to do other things. And so you have true cloud traceability of that identity. So that's the additional context that I overlay. It is the future of identity. If you had to think about a warning label for OAuth, it would be, OAuth done poorly is worse than anything else, right? It's actually, it sets you up for failure in ways you don't want to go.
Well, and I think also one, I don't actually assume that that all like network pros know NTLM and Kerberos, particularly if they haven't dealt with, depending on the level they dealt with in the Windows environments. I think a lot of it is like that stuff was pretty complicated. And then you got into SAML, which was XML and SOAP based. And then you get into the stuff we're most going to talk about today, like OAuth and OpenID Connect, which is, as Aaron said, it's more internet and consumer side is where it kind of originated. And that, I think all of it's confusing because it's just a different way of having to think about it. It's a legitimately hard problem. Like the nuances of OAuth and how you implement it. Like it's a standard, but like any standard, there's like 50 jillion ways that you can implement it, the good ways and the bad ways and the in-between ways. And then what Aaron was getting to at the end there, which is like this transitive trust or delegated trust issues, like where one thing's trusting another thing, and there's like this identity chaining or trust chaining stuff. Like these are like legitimately hard. I can barely cling on with my fingernails, and I probably spent 20 years looking at this stuff.
So yeah, let's pull back a little bit before we get too far in. My understanding is that OAuth is actually, or at least OAuth 2 is an IETF protocol, which might make some of our networking listeners a little more comfortable, right?
Yeah, it's a standardized protocol. Absolutely.
Okay. And the auth in OAuth is authorization, not authentication. And I think I'm going to mix that up multiple times during this podcast. So I have a jar here. I'm going to put a quarter in every time I do that. But let's start with a high level. What is OAuth? What is it designed to do? What is it not supposed to do?
I think I'll jump in and then Aaron will correct me because I think he may know some of this better than I do. So basically, auth, as you mentioned, it's a standard for authorization, but people get confused a lot because it almost masks the authentication piece when you use it.
Right.
The easiest example I give is, we're not doing the live video, but you guys see me. I'm holding up my phone. I have apps on my phone, like I use Blue Sky. And I'm pretty sure I assume it's OAuth. I haven't actually looked. My device can pull up my Blue Sky anytime I open it up, but I'm not logging in every time. So what does OAuth do? It is a way of basically, here's the easier way to describe it. You know how you go to log into something and there's lots of stuff where you've probably done this and it uses like your Google account and a page will splash up. What do you want to let this do? Do you want to let it read your calendar, read write your calendar, read your email, read write your email, something along those lines? Like we've all seen that at this point in time.
Right.
That's OAuth. It's not doing the authentication. You've already done that with Google, but what now is happening is Google is getting a trust relationship with whatever this other thing is, and Google's saying that for you, these are the thing, or for this relationship between this service that's going to do stuff with your email and your calendar, you've allowed it only read access, or you've allowed it read write access. So that's the core of what OAuth does. Now, where it can be a little bit gets a little bit more confusing is the way what happens is there's these cryptographic relationships and there's an exchange using your web browser that bounces you around, and then the servers talk to each other as well on the back end to establish that trust relationship. The end result is you're typically going to have two things given to the application that you're allowing access to your Google account with. It's going to get something known as an access token, which is here's the token that allows you to do what you're going to do within the limits. Because remember, it's not authorized to do everything. It's only authorized for whichever checkboxes you fix. So you have that access token. And then frequently you will also have a refresh token. The access token is very short-lived. And then the refresh token allows you to get a new access token. And here's the part that blows me away with all of this stuff. In the end, it's just like a bunch of text files. Like the entire internet and all of our security and even encrypted things, it's just a bunch of text files. And so there's all this crypto and everything else, but if bad guys can steal like that refresh token, and if there's not any kind of a token binding mechanism, which we can get into that, or client bind, I can't remember the exact terms all the time, then they can do like replay. So there's all the security stuff we'll talk about. But fundamentally, that's what it is. You allow either a client application or some kind of a server application to do things on your behalf, and you can restrict what those are.
So it's the authentication part has already happened. This is the authorization step saying this client accessing this resource is allowed to do X, Y, Z and not anything else.
Yeah, and then we kind of will layer in this thing called OpenID Connect, which is kind of like an add-on on top of, which does the actual authentication piece, which is a different federated authentication mechanism designed for the open web. You can use those independently. You can use them together, although Aaron, doesn't OIDC have a OAuth dependency? So, but Aaron's nodding his head, so I'm going to shut up and let him jump in here as well.
So in the world of IAM, we use authn and authz as the important thing to avoid putting quarters in the swear jar. Okay, so authn and authz. Okay,
authn being authentication, authz being authorization.
Authorization. Yep, exactly. So and the reason why it becomes problematic is because most of the time people consume this as a platform that's consolidated. So for example, the Oktas of the world, Entra ID, Ping, it's a consolidated authentication and authorization platform. So you sort of perceive it as this one entity. Now, very important to think through maximum potential for deployment for these things. So for example, in a consolidated OpenID Connect situation where you say, look, I want to do something like, I'm only going to issue an OAuth token for 4 hours to a person who has their phone and their laptop in the same place at the same time, and the laptop is properly federated to my core ecosystem. And so you see how I'm creating essentially in Entra ID land, this is a conditional access policy. Saying I've got to have all this stuff. Now, if all of these things are true, then I'm going to issue this token. And then back to Rich's point, that token has a scope. And now by default, and this is an error of our ways in the past, by default, many identity platforms, they didn't constrain the scope. And so a user could go, oh, I want to use this token to go sign up for a new Teams app, or I want to use this token to go do something. And it was up to the administrator to go clean that mess up. And so it's play whack-a-mole and say, no, I don't want my identity to be federated with ChineseHackers.com or whatever bad place that it was being taken. And so now, beginning in 2020, when the pandemic started, you started to see where identity scopes had to be whitelisted within identity providers. And that was a big step forward for the administrators of these things to go, I'm only going to allow a scope if I say it's okay. I'm not going to play whack-a-mole for trying to hunt for bad ones. I'm only going to allow the ones I want. And so that's a really important concept. So if people just walk away with one thing here, is that most of the time, auth-in and auth-z consist in a single platform. You have to contemplate the appropriate administration of that to block additional scopes from happening, because if scopes create problems for you down the road. And you need to monitor for the potential abuse of tokens that are issued from that system, unless you have compensating controls that bind the token to only my managed devices, or only this place and coming from this network, or other places to help restrict the way it gets abused. Through ION's research, I maintain a list of about 52 countries right now. They have the ability to sniff every single OAuth token in their borders, and they just take them and use them for what they want, right? Because as Rich mentioned, it's clear text, and they can do that. They can scrape it and replay it to their will. You have to also understand that the mobile ecosystem, which is the consumer world, is very, very advanced in the use of OAuth. That consumer ecosystem allows for the storage on the mobile device of OAuth tokens in ways that one single mobile OS vulnerability can expose. Meaning that if you haven't patched your iPhone, you haven't patched your Android phone, bad guy has you click on a link, that link goes, dumps the keychain, now all your OAuth tokens are gone, plus the cryptography to help you generate future OAuth tokens. And so that's one of the things, like done poorly, this is an awful situation. Done well, it helps you do things that you can't do in any other authentication or authorization platform.
Yeah, I mean, we did a lot of fears, but I think what Aaron was also getting to at the end is done well. There really are some great advantages. For example, I use secure enclaves a lot when I'm doing things. So like I'm doing some AI stuff on my local system that I've given access to some of my platforms. So Blue Sky and Mastodon and my email within certain limitations as much as I could based on the scope. And I put that in the keychain. That's kept on a secure enclave. That's tied in with. It doesn't mean it's not stealable, but it does reduce it. And especially if I move that to like a mobile device, like my iPhone, and then I can link it to something like Face ID, then you can start getting more limitations in. But those again, and that starts getting into FIDO stuff and everything else. But at the core, you have to protect those access tokens. You have to understand the scopes you're allowing your users, as Aaron was talking about, to do things. And you do have to understand that token theft, particularly if somebody compromises an endpoint, can be an issue in different kinds of token abuse. And we can give you specific examples in different flavors of that. And there's been some big breaches in a couple of cases around this. SalesLoft Drift was an OAuth failure. It was basically they had long-lived tokens that were able to be misused and get into a bunch of client environments.
Right. Wasn't SalesLoft the way folks got into big SaaS companies like Salesforce using OAuth tokens? Yeah. Okay.
Yeah. Exactly.
One thing I wanted to add is from a implementation perspective, Rich and I cannot be more different, right? Rich is a guy who lives inside of the Apple ecosystem, right? And I'm a Windows and Android guy, right? That's our preference.
Secure, but insecure.
Okay. And so,
hey, we try not to have religious conversations here.
but what I bring up is that we are having a common conversation here, right? Regardless of what endpoint you're at, regardless of that's the benefit of this, because it was done in a consumer world, right? It was done for Internet Explorer and Chrome, and it didn't matter, right? You had true heterogeneous outside environments, and so this becomes a protocol that works regardless of where you're at on endpoint and that sort of thing.
Yeah.
So in the functional world, for those of us that kind of tend to just throw around, federated SSO and all these words together, is OAuth what we're using when we, like Aaron, on the Entra ID apps? If we register an app and we connect it, is that an OAuth connection?
It depends.
Okay.
Okay. So, for example, and this is where people perceiving it as, oh, I bought Okta or I bought Ping or I bought Entra, right? Those platforms will serve up SAML, right? Heck, sometimes Jump Cloud will serve up LDAP if you want.
Actually,
right?
I do want to jump in quickly. We didn't explain SAML. So SAML, Security Assertion Markup Language, is an older version for handling federated identity. SAML does authentication and authorization. It's XML and SOAP based, still very widely supported, particularly not just in Microsoft, everywhere. I could do it in AWS, Microsoft, but the consumer world simplified things and made it more like REST API based for doing like over the internet stuff. So SAML was actually could be really hard to do across internet in places. It wasn't what it was built for. So that's when Aaron was talking about SAML and versus OAuth. There are two different families. Okay, back to you. Sorry.
So basically, it's up to the implementer to go, I only want OAuth to happen, which you can do. Right, so I'm only going to speak this. So it's basically shedding some of the problems of the past with SAML. And so at that point, you've turned it on, so that's what it's doing. So natively inside of the Microsoft ecosystem, like when you go log into your Exchange Online mailbox, even if you're using Okta as a separate platform, there is still an intra-Microsoft OAuth token that's associated with logging into that inbox or getting to your OneDrive or whatever. So this is one of the reasons why the NSA wrote a paper back in December of 2020, probably one of the most important declassified documents when it comes to identity in the last decade, easily. And in that paper, the NSA said, if you're using Microsoft, only use Entra ID. Don't stack other identity providers on top of it. And the reason why was because the Russians were using the diversity of Okta plus Duo plus ADFS plus all this other stuff. And they were essentially hiding from the NSA in these different identity providers. They'd go and live over here for a while and over there. So simplifying that platform, making it OAuth native is a very important thing to shed a whole bunch of identity vulnerabilities that exist in this complex ecosystem.
Then I guess expanding out, into all of the more cloud-based apps, Rich, is this, so one of the things I know we started seeing, I guess, last year at RSA, one of the common themes that was popping up was identity is the new perimeter and downscoping, identity and like what an entity or an identity could do, which is what this sounds like to me. Is that what we're using now in the greater hybrid environment?
Yeah. So the origin of that phrase, which I think I started using it probably 15 years ago, is if we think about what we have done and are doing with all these various cloud services, we've taken a lot of the back office stuff, the stuff that, back when Aaron was building AD was only meant to work within a data center or peered data centers. Those applications, your Salesforce and ServiceNow, your email, your everything you're consuming from internet services. So instantly, you have to have an authentication and authorization relationship. You're doing identity management over the internet. Now, the problem that we have is that you have these massive platforms where we run anything on them, and everything, you can't defend the network because they're on the internet. So what the attackers have shifted to largely. So one is they do still try to break into Microsoft and Amazon and Google. They are occasionally successful, more with one of those companies than with the others. I'll be nice today and not bring that one up. But those kinds of breaches get rarer with these larger platforms. Now, there's all these small SaaS platforms. They're garbage and it's a mess. But with those larger platforms, what the attackers realize is, well, I just got to, get some malware on your box, run some info stealer, get admin credentials, and now I own the whole platform. So that's why we say identity is the new perimeter. It was because as we moved into cloud, the control plane, the management plane was managed over the internet, and in some of these things with just a username and a password. And so losing that username and password gives somebody full admin access. They don't need to find a 0-day vulnerability or anything else. And those of us who spent more time in the cloud space, which includes, despite Aaron's roots, he's built cloud startups like I have, we have to take that focus on those relationships with customers and the different authentication and authorizations. And most of the major breaches we see now that are these big public ones are almost always identity based.
I think to add to what Rich just said there, it's important for people to understand the market forces that led us to this place. So, for example, when we were first building Active Directory, we were given one mission, and that was destroy Novell. Like that was the feature spec. Okay, it wasn't that complicated. It was like
didn't they do that all by themselves?
They took some pushing. They had to be pushed, but anyway. So what happened was Active Directory's dominant position became many CIOs' perception that they had an identity platform. Active Directory was never an identity platform. It was maybe an okay authentication platform for a Windows-based ecosystem, but it was never truly authorization or identity governance or federation or privileged user management or any of the other things that sit in the identity ecosystem. But what ended up happening was the perception among CIOs was, I've got an identity platform. I'm not going to spend any more on that. And so Active Directory warped the market. And what happened was, let's take a look at how many billions of dollars were spent on firewalls over the last 25 years. Like, how much money has Palo Alto made? How much Checkpoint made? Like, you look at the firewall market, billions of dollars spent over time, right? And if you look at how much money was spent on identity, it was a fraction, like a 0.00001% of that. And so as the result, when people say identity is the new perimeter, most organizations are woefully unprepared because they don't have the people, they don't have the infrastructure, they don't have the processes, they're just not ready for it. And so now, as people move towards where identity matters in a work from home environment or the new ecosystem, that's the market warping that we're dealing with. We have literally billions of dollars of debt when we say identity is a perimeter because we didn't spend billions of dollars on this problem like we did with firewalls.
And for enterprises, it's legitimately difficult because, and we're getting there now. I mean, I've seen dramatic advancements around SSO portals and everything else. But I still run into plenty of organizations that do struggle with this. And what we mean by that is, if we go back to where I was talking about earlier about all of these SaaS providers, if you figure, I'd say a reasonable number. Back when I worked with Gartner, there was a guy I worked with there who used to say he covered enterprise apps. And he said, on average, in a large enterprise, you're going to have one app for every 100 employees, one application for every 100 employees. And in that zone. So if we look into this SaaS, I think, for a larger organization, we do find that they have many dozens, if not hundreds of SaaS applications that their employers are using. Every one of those is an identity relationship across the internet. And so whether it's that one of 100 or one in 1,000, it might be that one SaaS app per every 100 employees might be a good average, or, gives you a rule of thumb. That's a lot to manage. And you have to manage all of that if you're on an older architecture, particularly, there are a lot of organizations that were still very heavily reliant on Active Directory because everything they've already built relies on that. Yeah. Now they're trying to move into this cloud world, and there have been transition pains. Some of them caused by the enterprises, some of them caused by Microsoft, some of them caused by the SaaS providers, none of them caused by me and Aaron. We're perfect. It's wonderful. And that adds to that technical debt that Aaron was just talking about and the complexity, because now we have to people go get something like Okta, because Entra isn't always the right answer for their organization, all of their other relationships. And then they have these vendors that they're trusting, because it turns out one of the dirty secrets of this is not everybody implements all of their identity stuff to the same level of the standard. Uh-huh. So like when we had to support in my platform, both SAML and OIDC, and by extension OAuth 2, to allow people to come in at the one that I built with when I was still over at Firemon, we lucked out in that we made the decision to use Amazon's identity platform as a basis. There still were a lot of headaches for us to support everything, but we weren't getting into like the crypto token level stuff. Aaron can talk about his most recent platform if it went the same way. But there's plenty of organizations, developers that are taking open source toolkits and trying to use that to implement their own way of doing OAuth. And instead of relying on one of these larger SaaS providers where they're hosting, and that there's a lot of room for error.
Oh, it's like when you meet someone and they're like, "Hey, I'm a computer science grad and I just wrote my own crypto algorithms." I'm like, "You are insane. That is insanity." Okay, you may have thought that you did something, but so that's what Rich was just mentioning there, is that people who go out and download some GitHub repo about, oh, here's an OAuth interpreter or whatever, it's like, you got to be careful with that stuff because it's super, super complex. I've spent my life on this stuff, and there's still areas where I don't even want to touch because it is fragile and it's easy to break and it's easy to clone. And so, and as Rich mentioned, the last startup that I built, we were using the Amazon subsystem for a lot of stuff, but still we had to go out and find a shim called Auth0, right? Which was this super awesome platform that could help you do things. But Okta realized that they were stealing money out of their pockets, so Okta went and bought it so that you couldn't use it anymore. And so anyway, well, you could, but under a much more expensive license. And so that's also the other thing that should be very important for people to understand here, is that the market is now penalizing people for trying to do the right thing in some ways, right? By saying, hey, I want to join things together. It's like, oh crap, in order to do that, I don't have the developers to do that. I have to buy this license. But now I'm triple licensed from an identity provider perspective to get all this stuff done. And that can be cost prohibitive. And so I think that there's going to, and I think Palo's acquisition of CyberArk really showed that there must be market consolidation in the identity space, right? Oddly enough, who had the most to lose in the world of identity as the new perimeter? Palo did. They bought CyberArk, right? And so I think you're going to see additional network-centric cybersecurity firms buy more identity stuff because of the importance that it's taking.
Well, let's kind of talk about some of the components, because I know as prep for this, you guys, somebody sent over kind of a diagram of how OAuth works. And I know we're talking about, a user and maybe a device and then like service A and service B. But I mean, I'm looking at this thing and it's 33 different steps with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different functions or entities involved in this. How do you,
because we're audio only. Because we're audio only, okay, let me try to build a mental picture for people. So what OAuth gives you in flexibility, it creates complexities in the way things have to be exchanged, right? So okay, it's flexible. You have this ability to work over the internet. As Rich mentioned, it fundamentally changes the trust boundary through which you can work. But by changing the trust boundary, it basically says, okay, Aaron, you want to go to this place, and the diagram that we're referencing is a mobile application, right? So this is a mobile app sitting on a mobile phone, but you're using maybe an enterprise identity to do something on that mobile phone. So you're on the mobile phone, you've got your user identity on the mobile phone, right? This is your consumer identity, your Apple ID or your Google Play Store ID or whatever that's there, that needs to then be chained with an enterprise identity. So you have to go to the enterprise identity provider that then needs to be associated with something like, let's say the Outlook app or whatever your enterprise email application is on the mobile device, that then has to be chained to an enterprise identity provider related to that, right? So now you have another chaining, which then has to be chained back to the phone to make sure that it's properly patched, right? So each one of those steps is a bi-directional ping, right? It's like, are you okay? Yep, you're okay. You're okay. You're okay. And some of those require administrative help to get done, meaning the enterprise identity provider has to open the scope to say, hey, I'm going to allow this mobile device to be associated with me. And so the reason why there's so many hops there is that each one of these points of flexibility becomes a bidirectional communications point that in some cases has up to 10 interactions, so sometimes even more, right? To say, are you patched? Okay. Did you MFA through an app? Did you MFA through a FIDO token? Did you MFA in this location? And so each one of those checks requires this. And so the reason why I think it took so long for us to get to OAuth is because OAuth needs really fat pipes to work well, really fat, fast pipes. And so the ubiquity of wideband internet, brought, very fat pipes has made it so we can do this now. But from an implementation perspective, I would say don't be afraid of all of those jumps and the 30 plus jumps on that diagram. Think of them as these are rational, logical steps that I want to do to verify the integrity of the system I interact with. And
it's like a slightly more extended TCP handshake for our audience.
Yeah,
to be more comfortable.
super extended TCP handshake that can do things like check the patch level of the machine you're on, verify what form of MFA you used, what time of day you did it, where you did it from. So you can do all these cool things to stack it. And I would say the most important of them all right now is what version of browser are you rocking? Because most of the what I'll call easily exploitable problems in OAuth are from an unpatched browser.
And HTTP is the transport, right? In OAuth?
Hopefully with an S.
Yes,
HTTP.
Yes.
Yeah. Now, a bunch of the things that Aaron said, looking for MFA, looking for everything else, this goes back to the implementation. And not everybody implements that degree. In fact, sometimes that can be hard to do. So like device pinning, it turns out that's actually can be a pretty hard problem depending on what platforms you're on. So your laptops and desktops are, for example, typically going to be higher risk than your mobile devices, where if you're on the latest iOS or one of the modern Android devices, not all the Androids, but modern devices, you can get to those, a TPM on a laptop, desktop, a secure enclave or whatever. There's other device identifier things that you can do around those.
Let's pause for a message from episode sponsor Meter, the company building networks from the ground up. Meter delivers full-stack networking infrastructure, wired, wireless, and cellular to leading enterprises. If businesses are frustrated with unpredictable pricing, IT resource constraints, complex, cost-prohibitive deployments, and fragmented tools, that makes it difficult to achieve the performance, reliability, and security that modern IT and operations demand. Well, alongside their partners, Meter designs, deploys, and manages everything required for performant, reliable, and secure connectivity. They design the hardware, write the firmware, build the software, manage deployments, and run support. You get a single integrated solution that scales from branch offices, warehouses, and large campuses to data centers. That includes everything from ISP procurement to security, routing, switching, wireless, firewall, cellular, power, DNS security, VPN, SD-WAN, and multi-site workflows. Thanks to Meter for sponsoring. Go to meter.com/packetprotector to book a demo now. That's meter.com/packetprotector to book a demo. And now back to the podcast.
It really is up to whoever is creating that trust relationship to require these things like, multi-factor linking to a device, any of those. And if you don't do that, remember, if somebody steals the token, and most implementations I've seen, they don't necessarily do device checks to make sure that token issued from that device. And so there's OAuth token theft. They'll steal the token and then they can run it from somewhere else until it expires. And if they get the refresh token and there's no pinning involved with that, then they can just do whatever they want for as long as they want.
So essentially we've got like a client, we've got a resource, the client's trying to access the resource. So it goes through this exchange and let's say this exchange has been successful based on the attributes. They get a token. What is a token? Is it some kind of cryptographic hash? Is it some string? What does it look like?
I mean, there's no difference between a cryptographic hash and a string. They're all just strings. So yeah, it's a string of text.
It's a string of text. Is it generally encrypted though, or is it?
It depends. If you're doing browser based, it's probably going to be in an encrypted twit. And I see Aaron laughing, so I'm going to.
It's one of those things where it just depends. Okay. Yeah. So for example, there have been situations when, not to pick on Opera, but back in the day, Opera wouldn't encrypt certain things, right? The browser, right? And so it could be that your auth tokens were encrypted. And a guy that Rich and I have worked with, Connor Peoples, actually did an analysis on the Teams app a few years ago, where he found that every OAuth token in Teams was in clear text. You could essentially scrape out all the OAuth tokens of Teams very easily. And so even within, and what was interesting in that process of Connor discovering that vulnerability, Microsoft responded by saying, "Oh, that's a feature." Like, whoa, wait a second. unencrypted OAuth tokens are a feature. Like, well, yeah. So the reason why we do that is because let's say that someone sends you a purview protected Excel spreadsheet, and Excel needs to read that token, then Excel needs to read the token. It's like, okay, I guess you're sort of right, but that sucks. So I think what's happening now is these implementations are having to catch up to say, look, let's create certain boundaries. So for example, in the Microsoft collaboration ecosystem, this is handled on an iOS device by saying, I'm going to use mobile application management that creates an enclave among Excel and Word and PowerPoint and Outlook. And the tokens are therefore encrypted inside of that enclave, which is the key store protected. And so that's what we're doing to try to protect these tokens, is we're essentially creating encrypted boundaries for them, but they leak in really weird ways. So they can leak sometimes between a browser and the Twitter app, or the Twitter app and something else, right? So basically or it's not called Twitter anymore. Anyway,
We
X,
still call it
whatever
Twitter.
it's called.
We call it Twitter. Yeah.
We call it Twitter. So I know in the past few episodes when we did news, we had a few news stories where, there were malicious actors that were tricking users into, connecting and authorizing malicious apps. And then we also had a news story where I believe there was something in the Azure CLI where they were getting the user to do something and then basically copy and paste a URL that had unencrypted
You're
OAuth
talking about
tokens?
consent phishing.
Yeah.
Yes.
Can you unpack that a little bit?
Yeah, consent phishing is when you can basically send a URL of some sort to the user that will, if you're an attacker, you have your evil application and you trick the user into authorizing your evil application. So they'll send a string out and it will they'll do it as a text message or as a phishing email, whatever. It's phishing. It's just phishing. But instead of phishing to steal their username and password, it actually sends them to the legitimate Microsoft, Google, Amazon, whatever, OAuth consent page, the one where you say, you've got read access, you've got write access, you can see all of my stuff. So it tricks them to go into that page and authorizing. Because of the way OAuth works, the browser is not the part of this that actually handles, the browser's like the communication mechanism. It's a server to server. Once they do that, that evil application has an OAuth token and an access token and a refresh token. They've got full access to all the user stuff. So that's what consent phishing is. And there's a lot of different techniques to do that. And for Aaron and I are about to at RSA talk about like mobile or AI related. This is one of the fears that one of the areas and there's some things we can talk about there, defenses that are available to that. But yeah, that's what that particular problem is.
So if I steal a token, do I have to sort of use it within that same existing session that I stole the token from? Or can I just start a new session with a resource and be like, got this token? Have I just bypassed the entire authentication step? And the resource is like, oh, great, welcome.
Maybe. Yeah.
Maybe.
So here's the thing. By default, and let's just pick Microsoft 365 because it's ubiquity, right? 90% of enterprises run on that thing. So by default, OAuth tokens can be valid for 90 days. So like so you steal the token at the access cycle.
Wait, is it the refresh token or the access token?
That's the initial access, right? And that gives you the rest of it, right? You can then build off the top. And so you steal that token at the beginning of the 90 days and you can do whatever you want. So for example, in the US government promoted hardening guide, which is called the CISA SCUBA guide, which is the secure collaboration business initiative or whatever, inside of CISA SCUBA, it makes it very clear that the maximum life cycle for both an initial access as well as a session token should not exceed 12 hours, right? And so for me, when I'm trying to do things, I actually like 4, right? Because 4 is like enough time for someone to have to leave their workstation and take a bio break, get a cup of coffee or whatever. And so I actually like even smaller timeframes for these tokens, because that means if the token does get busted, as far as initial access or subsequent brokered tokens, they've got 4 hours, right? And they've got to churn and burn. And generally in that time frame, and when I sold my startup to Vectra, one of the things that we spent time on was to detect the activity of bad guys when they're trying to use that short lifecycle token, which is churning. Like it causes them to churn very, very quickly, which is easier to respond to because they're trying to dump the entirety of someone's OneDrive in 4 hours. That's not a normal thing, right? I'm going to look at that activity associated with that token. So that's why you have things like Vectra, their cloud detection response platform now, which is looking for token abuse and activity associated with that token abuse. So that's how you basically have a compensating control for some of the fragility of this implementation.
We have a range of tools as well where you don't have to treat all access the same. So, for example, and this gets into other things like personas, but the way that, like one of the environments at my former startup, we had the developers go in with read access into production as they needed. But if they want to do any administrative functions, it was a just-in-time access, and it was a 1 hour timed session no matter what. There wasn't even a renewal. It was a whole re-auth mechanism to get in there. When you're in the Microsoft environment, for example, one of the big problems is people using global administrator and using that too extensively. And I go into places, one of the first things I'll ask is about global admin. And there are organizations that allow people to stay logged into global admin all day. That's horrible, because if somebody gets onto that endpoint, they can own the entire organization, as opposed to more mature organizations, which will only allow time-limited global admin access, or they'll require a second MFA when you go to, like, we have a lot of strategies, particularly in enterprises, to help protect against this stuff, to help limit it. Yeah, Aaron's showing his YubiKey. My YubiKeys are right here. Like, I travel with one. I've got three, because you don't want to lose those. So we have a lot of things that we can do, around persist. Anyway, we have a lot of capabilities. So I don't want people to think that this is a worse environment than we've been in before. It's the new perimeter where we learned how to defend our old perimeter. Maybe not perfectly, but we have techniques, and we have these identity techniques. It's just important for security professionals to understand those. And then as we move again into this more agentic driven world, we also have techniques we can adopt there, but it's up to us security pros to really promote those, because they're not like the standard that people are following.
So I want to take a little bit of time to talk about, just a few minutes, to talk about refresh tokens, because if I can already set up conditional access with an initial access token, what is the role of a refresh token?
So that's what constrains where you can go within the system that's authorized. So if my initial access gives me X, right, then that's where I can go and do other things. So for example, let's say that you want to go and do some Power BI work inside of the Microsoft ecosystem. My initial access gives me X, right? But let's say they need to go and gain access to some other things to make Power BI work, right? So that initial token can be used to say, oh, well, Aaron can go and gain access to this Azure storage blob to enrich this for right now, right? To go do that, to do these things. And so you can use it as a filtering mechanism and say, Aaron can do this thing to go do things. So think of it as applying role-based access control as you move through an ecosystem.
The access token's typically short-lived. It's what you're allowed to do at that given point in time. And the refresh token is just keeping your session alive, is the super simplistic way. They're typically, access tokens are exchanged more frequently, so they're more exposed. Refresh tokens only need to be used to refresh at the end of that particular cycle. For example, and I'm going to make this up, I could be wrong about this. So when I set up IAM Identity Center, the SSO over in AWS, I have it set so I can have a session can be 24 hours, or I can log in and it will auto refresh within that 24-hour period, and then I need to fully authenticate again. My refresh token is handled, though, for the individual, like those keys may rotate. My access keys that are being used are going to rotate more frequently within those 24 hours, because it's a different exchange. It's a different operation. So I'm calling the refresh my session, give me a new access key, which is different, or access token, which is different than the access token accompanies every transaction. Remember, this is all API call based. All the sessions are. It's not like you're an SSH over a command line or something. So the access token is being sent as part of those API calls, basically.
Okay.
And you can build interesting logic steps into, say, a refresh token can exist from the same IP address. If the IP address changes, then blow it away and you've got to get a new access token, right? So, which then force the MFA and that sort of thing. So that refresh token can also have logic built in to do certain things to help either prevent fraud, prevent abuse, or to make it easier for people to get work done.
Do we get to configure that as system owners, or are we living in the
well, it depends on the platform.
Okay.
In what I'll call the core enterprise platforms that adhere to the U.S. government standard, meaning that they have a FedRAMP capable, so that would be Entra, Okta, and Ping at this point, right? So in those three biggies, all of this is configurable to infinite levels of seconds. Like you can literally crank it to seconds if you want.
Wow.
But most people don't look. So that default of 90 days Aaron was talking about, and how long the access tokens live, refresh tokens in Azure can live even potentially longer, or in Entra. It just, and again, there's legitimate use cases because you don't want to reforce a user to log into email like an email client running on their system. I'd be pissed if Entra made me like relog into Exchange, every 90 days even.
Well, and I like the the IP matching, but if you figure somebody on a phone that's running around out in the world, they may be popping on and off of Wi-Fi various places and having different external IP addresses. So, I see how that gets complicated quickly.
I think and we want to spend a little bit of time on non-human identities here. So let me give you an example. For example, a long persistent OAuth token could exist between GitHub and Azure DevOps, or whatever you're using for your pipeline management, right? So like that, and that's one of the reasons why you should be actively scanning for static OAuth tokens inside of your code bases, right? You do not want that stuff sitting in a repo where someone could replay it and do bad things. And so that's a situation where, for the sake of someone getting work done, right, I want to be able to publish things rapidly. I'm going to associate a trust relationship using OAuth between GitHub and my DevOps platform. Now, the situation that we see coming up over and over again is where people don't understand how those things can be abused, right? That if I get access to this repo, well, does that give me a transitive relationship to this repo? And could I potentially shove malicious code through that? I'm going to use the persistence of GitHub back into this thing to do my badness. And so think of it as from a good old-fashioned networking perspective. People should think about running like the equivalent of an Nmap scan on everywhere that you've got OAuth tokens persisting, right? Like where does all this stuff go? And that can be hard. One of the tools I like to use if push comes to shove and I've got to do something quickly, I actually load Burp Suite, right? Load Burp Suite, go through the process, and Burp Suite is going to spit out all the OAuth tokens that it's catching in that workload. It's like, oh, okay, I have 15 OAuth tokens when I'm trying to get this job done. What's the scope and who's the issuer of all these things? Wait a second, I've got 3 OAuth tokens I can't find the provenance for. That's a problem, right? Someone, maybe accidentally or purposefully, is injecting their authentication and authorization flow into my process. Why? There can be legitimate reasons. Like, for example, you need to do a Salesforce integration in a mass mailing or something like that. And so you've got to have your Salesforce OAuth token that's authenticating as part of your GitHub process, that's part of your whatever. That can be legitimate. But if you think about ways that bad guys do things, they like to hide in that area that people aren't paying attention. And this is an area that a lot of people aren't paying attention to right now.
And there are some really cool, interesting things that are emerging or even have been around for a few years in the non-human identity world that can harden some of this. So it's basically Spiffy is one of the ones that I've spent a fair bit of time. So that's a standard around non-human identities. But with Spiffy, it's like for containers and serverless functions and things like that, where the identity is based on attestation. What does that mean? Well, instead of you running a container and embedding a certificate or embedding a secret code, the platform where that container is running, Kubernetes, Azure, Amazon, or whatever, it will actually inject an attest that thing is running inside of my environment and has met the criteria to run. And then, that can be the basis for your OIDC and your OAuth if it has to talk to other things. But we have some pretty cool capabilities, and there's emerging platforms. So if I look at agents, and for example, I'm going to want to use something like Spiffy, and in the ecosystem of the agent, Amazon's got something called Agent Core. I know Azure's got theirs. I just can't remember the name of it, which is like an entire framework platform. You still code your own agents, you do whatever you want, but it uses a gateway, and it uses this whole attestation concept to say, yes, that agent is the agent it's supposed to be, and it's allowed to talk to these things. And we're going to mediate the identity management around that, as opposed to the cruddy stuff I'm just running on my Mac here at home because I coded it myself.
So that we'll see how geeky your listeners are. Okay. So like, so back in the 1999, 2000 timeframe when I was at Microsoft, we built three things to work inside of IPsec. Most people perceive IPsec as encryption, right? This is the way I encrypt things. But IPsec also has a filtering mechanism as well as an authentication mechanism. And so when Spiffy and Spire was getting started, I leaned into those guys and said, look, back in the bad old days of Windows, one of the things that we did, you could turn on IPsec policy that every port had to have an X509 certificate to mutually authenticate the traffic between those ports, right? So for example, 443, you could do TLS mutual auth, but you could also do IPsec mutual auth, at a much lower layer than that application layer. And so what Spiffy and Spire allow you to do, think of it as mutual TLS on a per application basis. So for example,
this app instance of the application.
Per instance, infinitely architectable, right? So like this, let's say I've got 15 nodes of a Kubernetes cluster that I have to horizontally scale very, very quickly, right? So, and Netflix is one of the ones that really drove the viability and the maturity of this. Is like when 10,000 people want to watch Stranger Things at the same time, they can't serve it up from the same instance, so they'll scale horizontally really quickly. But that means they have static creds in each one of those VMs or each one of those Kubernetes clusters. And so what they do to make sure that there's integrity and confidentiality, each new Kubernetes cluster gets stood up gets a new Spiffy identity, which has its own X509 cert that gets pinned to that identity, and intra-cluster communication is mutually auth and mutually encrypted. And so that's the power of using Spiffy and Spire now. So let's say, for example, I just wrote a paper for IANS where think about it as you have a multi-MCP situation. So it's not just one MCP, but you have lots of MCPs that are teamed together. What you can do is you can issue each MCP server its own Spiffy Spire identity with its own set of certificate, so that every single MCP interaction is now avoiding. There's a CSA framework called Maestro, which is a threat model for AI, and there's one of the layers that talks about, essentially moving to a situation where you don't have to worry about the repudiation of sources on the back end of AI, where you can now attest to say, I know that this MCP server talked to this data set, and it then returns it to this agent. So now you have complete ecosystem integrity, mutually auth, but from a certificate perspective, plus the OAuth identity traveling inside of it that gives you the user token to do RBAC inside of that session.
I can see a framework for conditional authorization being important in an agentic environment.
Oh, heck yeah.
Yeah. Because you're also getting you have agents acting on your behalf. So there's, on behalf of permissions. So that's a specific phrase of like, are you allowing this transaction is only allowed for this agent on behalf of this user? Like, so I would be, say I'm the admin, that agent could work on my behalf and do admin things. But if Aaron's not the admin, that same agent would not be able to do on behalf. And then to have that as basically being fully traceable as well is like a huge part of it. And to know what those are, I mean, these are problems we do know how to address. They are hard, and we're trying to help get people thinking more about this stuff.
Does MCP have support for OAuth, or is that something that I bolt on? Or
if you want.
I laugh because when Anthropic released it, it didn't have any OAuth support. It wasn't until 8 months after release that they finally started thinking about this. MCP violates every aspect of the stride model. Like if you wanted to think about, like if you wanted to completely violate every aspect of threat modeling, MCP server does it. Right?
But that's changing, you said, yes?
Well,
slowly. It's moving fast.
Like this all, like a lot of us talking about this was Aaron and I were sitting at an IANS event back in, I don't remember how many months ago.
October.
Yeah, or something. And like just at a table, we're like, this is a problem. And yeah.
Well, and just quick teaser here, you guys are actually both speaking together on multi-MCP and multi-agent security, including some OAuth things at RSA at the end of March on Wednesday, I think, right? You don't know when you're speaking. I know when you're speaking because I looked it up.
Yeah, at some
Yeah.
point we'll even talk about what our content's going to be.
Yeah. Uh, so I think, with if I were to tell practitioners about non-negotiable things they need to do, right? What are the things that they need to go and say, look, these are my novice or beginner, newbie OAuth things I've got to do. Because most enterprise admins who were formerly network admins are now being shoved into the cloud admin role. So what are the minimum things they need to do? Number one, if you haven't looked at the Scuba guide for minimum configuration, go do that. It has some great tips right there, right? Well, things that you need to do. And I'll summarize what that is. Number one, block all scopes from your enterprise IDP. Only explicitly allow the scopes that you approve, right? So don't let users, so the OAuth phishing consent attacks that Rich was talking about before, in some cases, people could trick users into associating your Entry domain to an entire new scope if you haven't properly hardened it. And that's a bad day, right? Because not only has it tricked this user, but now you get all the rest of the users too. So you want to limit that scope. Step two, reduce token lifetime, right? Make sure that you have cranked those suckers down. Go and talk to whoever is responsible for your human capital management, HR, whatever acronym people want to use for it now. Talk to them and say, what is a reasonable work experience for people? Like what are people working 18-hour shifts? Okay, then 18-hour tokens. Okay, they work an 18-hour shift, right? But if they're 8-hour a day knowledge workers, then they don't need an 18-hour token. Like build your scope and your session times to what a reasonable employee of the organization does. And the last thing that most people don't do is they have not turned on appropriate logging for where all this stuff is coming from and where it's being used. And so now that is a fire hose of information that most people are not prepared to deal with. And so that's where buying an identity threat detection response platform is important. Right? And luckily, these things are not astronomical in cost. Okay, it's something that you can consume as a cloud service, can do things like identity threat and detection filtering to plug back into Splunk or Elastic or wherever you're trying to do your SIM stuff. Like there are decent options there to help you look for things like token replay, suspicious usage of token across services, scope amplification, things like this. And so there's my 3 things I would do. Rich, what would you add to that?
I mean, I would add one is for me, understand that for administrative functions, Aaron's advice to use short-lived sessions becomes just in time and much smaller, tighter sessions for any of the higher level admin functions that you're going to be using because, again, you don't want a token theft and somebody be able to come in as global admin. And that is a real source of breach that we've seen occurring out there. Identity security is also device security. We're seeing now this onslaught, and it's been going on for a couple of years now. It used to be that the attackers were using info stealers to get usernames and passwords. Info stealers are actually pulling tokens now, in particular, some of those longer lived tokens. And that's why, again, this ties back into Aaron's advice around having those shorter token session or shorter refresh cycles. Use my words, Rich. And that becomes really critical and important as well. And the third is we may even confuse people a bit more today because we were throwing out a lot of terms, SAML and OAuth and OIDC and talking about consents and exchanges. We didn't even get into weirdnesses, bearer tokens, and we talk about on behalf of and all of those kinds of things. At the basics, it's understanding that you are always going to have a trust relationship, and it's understanding, making sure that you know what those trust relationships are and what your users are capable to do. Because a lot of the defaults today, especially, are too open. Microsoft Entra IDs, by default, Entra ID today, at least, I don't know when they're going to change it. Any user can consent for any application. And that goes back to the scoping issue that Aaron, again, brought up. So I think I'm just repeating your stuff with different words. It's good. It's easy to go second, but trying to just provide a little more context around that. So I think the one different thing is for like your admin stuff, privileged identity management, privileged access management, and just in time becomes important. But for all the other things and getting into the core around OAuth and everything else, just the defaults are likely going to be too open. Have an understanding of what those are, have some good rules on the road, and be really good about don't trust those refresh. Those are designed for usability, so users don't complain a lot, and you need to tighten those up.
So if I'm just a network engineer or a security person and thinking I maybe need to just go check out this OAuth thing, I am looking at my Entra instance or Ping or Okta. Is it likely my organization has set up an OAuth infrastructure that's sort of outside those things, or where do I
I've seen it.
where do I find OAuth tokens and places to make these
Well, they're
settings
in
easier?
your browsers.
Well,
Okay.
but to find the source, the right question is, what is my single sign-on platform? Like that's generally how this started. Which
Okay.
platform are you using for a single sign-on?
Mhm.
And I remember working with one consulting customer, where they had written their own. They had literally written their own, and so it is complete. It is within the realm of possibility that someone has it running on a server underneath their desk, right?
Mhm.
So like now, the vast majority of folks have not done such crazy things, and they're using off-the-shelf, commercially available things.
Mhm.
Which, the big players in this world, we've mentioned Entra from Microsoft, Okta, of course, Ping. Ping acquired ForgeRock, which was another long-term player in this world. You've also got the likes of Oracle and IBM has one. And so basically you go and whoever your identity provider was, that's where they go to look for these things. Now,
Okay.
the actual checking of the settings, it is completely different in each platform. And so this is where you go to your large language model of choice and say, on this insert platform X, on this platform, what's the easiest way for me to check the session lifecycle?
Mhm.
Right. On this
Mhm.
platform, how can I check for elevation of administrative duties, like what Rich is talking about? On this platform, how can I do X, right? And use that large language model to do just-in-time training to find, I need to go to this menu on this thing, because none of these platforms were designed for usability. Like the settings are in really weird places. It's not intuitive to find them. So use your large language model of choice to find how to get to these settings.
Okay.
And prioritize. Start with the really important ones. So your IDP, and again, Entra is a huge part of this. Even if you're using Okta, you're still using Entra. If you have anything Microsoft, you cannot get away from not using Entra. And then the Salesforce and the ServiceNow and the Box and whatever or Google Workspaces, whatever your major platforms are, you can start there. And maybe that's going to be a list of under 20, which that actually becomes relatively manageable. Then you have to start getting into the smaller runs, because again, the core of what this came from is this whole conversation is about your users authenticating and authorizing using services scattered all over the internet.
Mm-hmm.
And you're going to have a lot of those. So just focus on the ones that are going to hurt you the most.
Well, thank you for spending so much time on this. And I feel like we've probably barely scratched the surface, but there's really good information here for folks to get started. Rich, I'll start with you. Do you have stuff online where people can find you, things you want to promote? What are you up to?
Yeah, so most of my blog level writing is over at the Cloud Security Alliance, so cloudsecurityalliance.org. I still also have stuff at securosis.com, and I run Cloud Security Lab a week, although it's not, I'm on a 6-week break right now after year 2 of that. And that's SLAW, Security Lab a week, at slaw.securosis.com. And then also, if you're an IANS client, I'm IANS faculty member, as is Aaron. So you can find me over there if you want to have a conversation.
And Aaron, same question.
Yeah, so the best place to find what I'm working on is LinkedIn. You can see the stuff that I post up there. Sometimes it's just articles that I write for LinkedIn. A lot of the times I am working through the IANS faculty, though. I really love what IANS allows me to do. Number one, is behind a paywall. It's NDA. I can do things there that vendors don't sue me for. So I've published some stuff publicly at times that
vendors don't sue me for yet.
Let's just say that I made the mistake of publishing some of my Apple research publicly and suffered the brunt of Apple's lawyers for a little bit. And so now I just publish that stuff on IANS.
Nice. All right, well, we'll have those links in the show notes. Thank you both for being here. And thanks to our listeners for joining us for this episode of Packet Protector. If there's a topic you want us to cover, or a comment, or a correction, or a question, you can reach out at packetpushers.net/FU. The FU is for follow-up, and we love it when listeners reach out. Just to let you know, Packet Protector is part of the larger Packet Pushers podcast network. We have over a dozen technical podcasts for your professional development on networking, security, IPv6, DevOps, and more. We've got our industry blog, 2 weekly newsletters, our community Slack group, a YouTube channel, and even an IRC group. You can find it all at packetpushers.net, and always free with no login required. And just a reminder, we just released our salary survey. It's our first ever salary survey, 418 respondents, lots of good data and lots of good charts and visuals to chew over on that. Also, packetpushers.net. Thanks for listening.